Hello and welcome to another ventilator related video. The date is the 2nd of May 2020. Today I'm going to show you quite a different device that I put together for squeezing regularly a BVM device, a bag valve mask device. What I'd first like to say is thanks very much to Intersurgical for supplying me with these BVM devices. They've supplied me with quite a range and some extension hoses as well, so that just gives us a little bit more to play with and demonstrate with. I'm very grateful to them. We have asked another BVM supplier and they weren't able to get back to us, so I'm grateful for Intersurgical's help with this project and future projects. So today we're just going to look at a small device that I put together quickly. I've pulled a controller that I put together for another purpose, actually a bottle washing machine, and I've repurposed it for this. So it's got a few extra buttons and controls on it that it wouldn't normally have had, but I didn't want to pull it apart, so I just left it together as much as I could and put a new program in there to control this BVM device and the process of squeezing it. So let's have a look at what we've got here. Underneath here we've got a NEMA 34 stepper motor. It's running at 24 volts, could probably be run higher. I tend to like to working with a lower voltage because I'm a bit slapdash. So we've got a 24 volt power supply here. Under here we've got an Arduino Mega. Here we've got a stepper motor controller, DM556. All of this equipment's worked very reliably for me in the previous projects. 4-line LCD display, and you can see here we can set both the cycle time and the magnitude of the cycle, the magnitude of the squeeze to vary the tidal volume. So let's just set the machine in motion. So always, when I press stop, it will always stop at the minimum tidal volume. So then it always starts with a pumping breath. It can be made to go faster and slower. It can also be, the tidal volume can be increased and decreased. And when it's not working, when we've stopped it, we can also just adjust the starting tightness of the band across the top so that it's set up correctly before it's run. So it's very simple, very pragmatic, there's not much to it. Underneath here I haven't put any guides for this band squeezing the BVM device. Really I should have put some guides here, paid a bit more attention to this and the way it's squeezed, but I'm not saying there aren't gazillion refinements that could be added, but it works adequately for demonstration purposes, and that's all it is. It's a technology demonstrator. It's an idea that can be put together very quickly if you happen to have basically a stepper motor controller, an Arduino and a NEMA motor. This motor's a bit big, could probably work with a smaller motor, could probably work with a smaller motor still if I'd put a gearbox on it or had a motor with a gearbox available, but that's all I had available. As I say, there are simpler ways of setting this up. Potentially you could do away with the stepper motor controller and work with some MOSFETs to switch the power going to the stepper motor, but I've never done that. I'm pretty sure it's pretty easily done, but I've never done it. The Arduino, simple enough to program. I guess that code there is I don't know, 200 or 300 lines, not very much. Okay, just let you watch it for a little bit longer. The next video I produce is just going to be a quick discussion about all these sort of very primitive BVM pumping devices. I'm hoping to produce that in the next half an hour, so with a bit of luck these two videos will come out together, just talking about what different groups are doing and where I think further work should be done. Not that I don't think it's going to be done by me, but where perhaps groups could be looking. Okay, well, thanks for watching this video, and I hope you have time to watch the next one, which should be out very shortly.